So I thought it'd be a bit interesting to look at the force data set and try and predict some of the missing log entries. So you can see there I've got the downloaded log details. I'm just going to fire up a new Python notebook and let's give it a new name. Okay, so I'm just going to set up the notebook and then we'll crack on with doing things like installing packages. Okay, right, I'm just going to import the packages that I want. So pandas, of course, NumPy, and then we'll import matplotlib for visualizations. And Seaborn for better visualizations, and then time to import the machine learning stuff that I want from sklearn. So I'm importing a few things here. What I should mention is that I've just picked 4 models. To be honest, I've not particularly put too much thought into it, other than choosing regression models because we're trying to predict the value. Obviously, if you're doing this in real life, I would really suggest thinking carefully about the models that you're choosing. Okay, and then inline. Oh, right. Oh, import spelled wrong. Okay, let's get on with it. So I'm just going to import the log data from that CSV file that I showed you at the very start. Not a day for spelling. And I just want to quickly show you something. Look at the head of the data. Look, if we can see that they've used a semicolon to split up the data, so we're just going to have to add a different separator in at the read CSV file. Let's look at the log data again, and there we go. Okay, so now just have a quick look at the data in the head there, and we'll have a look at some other ways of visualizing or of viewing the data. Okay. And as we can see there, roughly 1.2 million instances with 29 features. So actually quite a large data set. Now I'm going to remove, or I'm going to count the non-numeric, the NA, not NAs in the data set, and get rid of anything that's where the data is missing and so forth. So I'll be doing it a couple of times, and I'm just going to put things in a function to make it easier, so I can just call it again and again. Okay. Okay, so let's start making a table. The data frame. Yeah, I'm going to sort it so that we start at the top with the fewest NAs proceeding as they get greater and greater. Okay, so let's just test the function. Okay. Oh, goodness. It really isn't a good spelling day for me at all. Oh, God. Right, what have I done? Oh, let's just have a look. Okay, there we go. And we can see everything ordered there by NAs. So, again, I've not really put too much thought into my data selection, which is terrible practice. I'm just choosing everything where less than 50% of the data is missing. And then the two logs I'm going to try and find. Okay, so there we go. Right, so we're just going to drop all the NAs and reduce that data set, because you can see we've already reduced it in the number of features from 29 down to 18, but then we need to reduce the number of instances as well, and make sure that we don't have any NAs cluttering up our data set. Okay. Okay, let's have a look. And there we go. You can see we've dropped all the NAs. And you can see again, our data set has been substantially reduced from 1.2 million instances down to about 193,000. So this is definitely a more manageable number. But we're going to reduce it further because the data set is defined, or there's a column declaring the confidence that the interpreter has in their interpretation. So we're going to choose only columns where confidence level is at its highest, which is 1. So looking again, reduced it by another 15,000 instances. So next thing, we'll just have a quick look at the correlation plot for the numeric values. Okay. Okay, make sure we put our annotations in and that they're in a reasonable size so they're not overwhelming the plots. Okay, just choose our color map. Oh, forgot about it. Oh, no, more than that. What have I done? Oh, right. Okay, so there we go. We can see our correlation plot between the numeric features. Okay, so next we need to extract our target and source, or target and predictor data sets. We're going to try and predict the spontaneous potential log and the neutron density log, and for no other reason, neutron porosity log, and for no other reason than they were at the end of the list. Okay. Okay, let's have a quick look at what's going on. Okay, interesting. What we can see there is that formation group is still a non-numeric data set. So what we'll do is we'll just one-hot encode them and create extra features. So here we go. Right, group. Okay. So, and there you go. We can see that all groups of formations have been one-hot encoded. So the time for training test split. We'll split it into 2 training and testing sets. Okay, and now it is time to make up our pipelines to do a bit of let's just and then let's go back to support vector machine. Can run it first, can I should say, actually, at this point, these are not the hyperparameters I've selected at random. I did actually run this earlier, and I used Grid Search TV to do cross validation and select the optimum parameters for these models and this data. Okay, so it's the pipelines. Okay. Time to fit the training data. Let's do it for all the other models. Right. So let's run those, and that's going to take a while, so I'll be back. Okay, so there we go. That's the fit. That's fit to the training data, and now we're going to try predictions of our test data. So here we go. Linear regression first. Okay. Go. And pop, pop, pop. Right. Edit models. Okay. Right. Okay. Now, time to make the predictions. Oh, hang on. Oh, God. Right, okay. There we go. Let's leave that to run. And, yeah. Okay. Right, there we go. That's the predictions done. So I'm just going to run a quick function because I'll be plotting the data again and again and again. So I'm just to make my life a bit easier. Okay, yeah, scatter plot with a regression line. Or sorry, I should say joint plot because we'll have histograms as well. Okay. Title is okay. Here's a regression line. Make sure that we can see it. Okay, I'm actually just going to copy in some functions from elsewhere, just so that we get our key metrics. Okay, let's check. Put in the predictions in the correct labels. Get ready to run my function. Ew. Oh, God. Yeah. Okay, let's run the function again. There we go, there's our metrics. And we can see our lovely graph. Okay. So let's just have a look at residuals and make sure they're more or less normally distributed. Right, so let's get this all set up and quickly for all the other predictions and stuff. Okay, and then just run them all. We can go back. And there we go. We have all our various models, predictive data plotted, residuals plotted, and metrics printed out for us to assess how well each particular model has done in predicting our missing log data. Cool. I hope that's been of interest to you. Yeah, hope you find it useful. Cheers.